The 3 nails experiment is a simple demonstrator that makes a fundamental point. Electrical currents flowing through metal in contact with an electrolyte cause measurable metal loss. In laboratory form, it shows qualitatively how stray currents find paths through conductive structures and how these currents accelerate electrochemical dissolution at weak points. The power of the demonstration is not in its complexity, but in its clarity. It turns an invisible electrical phenomenon into an observable, repeatable effect that everyone can understand. Why this matters for pipelines is straightforward. Conventional pipe-to-soil potential readings are a difference between 2 variable points, not an absolute measurement of corrosion current. That floating voltage can be misleading unless you can fix one potential and measure the actual current that is doing the dissolving. The Alexander cell was developed to provide that fixed reference and to measure current at the corrosion cell itself. Once you can measure current directly, you convert uncertain inference to verifiable data. Field survey techniques such as CIPS and DCVG are invaluable for mapping coating faults and signals across networks. But without cell-level current measurements, they cannot, on their own, resolve the real activity at the metal to electrolyte interface. Hundreds of millions, even billions of survey points exist worldwide. Manual interpretation of that volume is impracticable and, crucially, can perpetrate errors if the underlying measurements are not anchored to true current values. Only by combining survey coverage with Alexander cell type measurements and automated analysis can we scale reliable interpretation. That is why data integrity and computational analysis are central to modern investigation. The CPN console and CPN blockchain approach link field sensors to algorithms that process data at scale, timestamp results, and preserve provenance for peer review. When measurements are immutable and traceable, hypotheses can be tested, models validated, and conclusions defended in scientific, regulatory, or legal forums. In short, measurement plus trustworthy data management is what converts a compelling hypothesis into actionable evidence. Finally, scientific communication matters. The 3 nails experiment and related demonstrations are pedagogic tools that help engineers, investigators and the public see the mechanism behind accelerated corrosion. But science must always return to quantifiable evidence and independent review. If we cannot explain a finding simply, we ought to re-examine it. If we claim an explanation, we must publish methods, data and analysis for peer scrutiny. That discipline is the only reliable path from suspicion to truth, and it is the foundation of the Cathodic Protection Network course and our investigative work.